Okay, I think the record is back on. So, right, one more thing. Let's go to this. So for LIFD, we use this. So you should see the steel structure, regardless of the design concept that you use, the behavior is the same. So the way that we use to calculate the nominal strength is always the same, regardless of the method you use, whether or not it's ASD or LIFD. The calculation of the nominal strength is the same. The major difference is that if you want to use the ASD, you must divide your nominal strength by this factor of safety. This is factor of safety. And in LIFD, you must multiply with reduction factor. So the common sense will tell you that the factor of safety should always be greater than 1, because we want to make sure that our design strength is safe. So if we are going to divide our nominal strength, we must divide with number greater than 1. In the meantime, the reduction factor should be less than 1. Okay. Now, I think you should know this. So I'm going to tell you, because you should, upon graduation, you should have this kind of knowledge within you. The Building Act of Thailand, currently, they only have the law for the steel structure based on ASD. Thai Building Act. For LRFD is pretty obscure, to say the least. So if you are going to have to abide by the law, for example, if you are working with the buildings owned by the government, you need to make sure that you follow this Thai Building Act, which states only the ASD load for the steel structure, and therefore you automatically will have to compare the forces analyzed from the service load with the resistance based on ASD. And predominantly in this class, I will try to adhere to this. Okay. So we are pretty much here. Okay. All right. So this is the design concept as a whole. So I think now it's time for us to get into chapter 1, just get to know the basic of the steel structure. Oops, I'm sorry. I browsed through it this morning. Got to bring it back to the first page. Somehow takes forever. Looks pretty long, but it's just a lot of pictures, okay? And I don't intend to go through all of them. Okay, so this has been pretty much covered in the concept, but now I think we need to know the shapes, and then of course the materials that we use. Okay, forgive me if I forget to tell you this. This is chapter 1. Which you guys should have the file already. So if it's to your convenience, you can just open the file and just, make notes on them, or whatever you think is best for you. Okay. All right. So generally these two are already covered in the first hour. So this is the property of the steel as a material. Have you seen this before? Maybe. This is the no response anyway. So this is what the property of the steel looks like. If you take the steel coupon into the lab and then you pull it until it breaks, this is the relationship of the stress and strain you're going to get. Okay, so this is stress and this is strength. So upon this, let's say you can see that this is a straight line. So it's a proportional limit here, right? Your steel will behave linearly up until this point. That is called the proportional limit. And the ratio of the stress and strain comes to be known as the Young's modulus or modulus of elasticity. Now, regardless of the strength of the steel you use, you always have one particular modulus of elasticity. So, are you okay with the unit kilogram force? Or would you like to use the Newton? No answer. So I think because most Thai engineers use the kilogram force unit, and I am quite familiar with that. So let me stick with that. Okay. The Young's modulus or modulus of elasticity of steel is roughly, to be exact, is 2.04 multiplied by 10 to the power 6 kilogram per square centimeter. Okay, you can say 2 million, that's fine. It's just missing 0.04, that's fine. Okay, once we reach this, now this is the first yield, so this is the yield stress of the steel. Now, once after you reach the yield and you keep pulling it, it's going to reach the point where the rupture is going to occur. Say this is the first yield. So we call this yield stress. Okay, and once here, your the structure will be ruptured into two pieces. So here, the rupture failure is going to occur at the ultimate strength. And we call this FU, or the ultimate strength. Okay, so that's the basic idea. And, we can skip the part where, you know, the cross section will be reduced. So therefore, we call that the straight hardening and blah, 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 blah. Okay, the important characteristics of this is the first yield and the ultimate strength of the material, and of course the Young's modulus. Three things. Okay, so now the Young's modulus will remain the same regardless of the steel grade that you use, but when you change the steel grade, we have more than one grade that you can choose. So okay, this may not give you the proper idea because it's kind of small. Try to expand that. Okay, in the Thai market now we have SM400, but the thing is that somehow they got things mixed up, and even though SS400